What's up, friends? Today we are back with Black Mamba. If you guys recall the last part in the series, I assembled the mechanical system, put together belt drives, put the trucks on the deck, and today we're going to be building the battery. Now, this battery is a little bit different than all of the ones I've done in the past, and it's fairly large, coming in at 14S6P, and this deck has some unique properties in that it is slightly flexible, and slightly flexible means that you cannot build a rigid pack, because if you build a rigid pack, you're going to end up breaking welds. It's just what happens. So today we're going to be building a flex capable pack, and we're going to be fitting it in this enclosure and cutout combination. Now, you would think that this cutout might restrict you a little bit, but it really just tells you the best way to build the cells. So today we're going to be building that battery, and hopefully through this long journey you will find something educational or useful to help you on your own battery building journey. Now, let's go ahead and jump right into it. All right, so we've got a lot of batteries on deck here right now. This right here is my 14S6P. Well, it's not anything right now, it's just a bunch of cells, but this will be my 14S6P for the Black Mamba build, and this right here is my 18S6P for the race board. Now, both of these are in this state of progress, so I don't know where this will end up in the recordings, but this is just how it happens to be lining up. So tonight we're going to be gluing up these. Well, first I gotta put all the Fishpaper rings on, glue them up, put the fish paper on, and then I'm hoping to get to welding these 6P nickel strips. So we will be using these 6P nickel strips to weld up all the cells together. We'll make it super easy. These are straight. So yeah, pretty much all we've got to do is get to work. So for the Black Mamba build, which is what I'm working on right now in this video, I'm gonna go ahead and put all the Fishpaper rings on real quick, and then we will start gluing them up. All right, so I've got all of the Fishpaper rings on the cells, so now it's time to glue them up. Now, technically here I'm using cells from two different age groups. One is the 2MB16 date code, one is the 2L711 date code, and they're a tiny bit out of voltage balance, just a little bit. Now, this pack is for me, so I would never use cells from different batch on a customer's pack, but for me, I'm totally fine with it. The difference in capacity between them should be very, very minimal because they're all brand new cells from a trusted source. So that's why they're in two different piles here, because I'm going to be mixing the two batches. Again, not really a big problem. Wouldn't do it in a customer pack, but we'll be doing it tonight. So I'm going to go ahead and get these glued up. I'm probably just gonna put like one or two clips in here because I've glued so many cells at this point and it's not really that interesting. So let's go. All right, so we've got all of our cells here. I just showed some B-roll of that. They're all glued up and ready for fish paper. So now it's time to cut down all of the fish paper with my trusty Amazon Basics knife cutter. So, gonna cut up all these strips, and then we will move on and get them all wrapped up. There's 1 out of 14. All right, we got all of our fish paper cut up here, and now we're ready to wrap all the cell groups
and put some glass fiber tape around them to keep them nice and tight. So let's go ahead and start doing it. The way I normally do this, I've probably covered this before, but I use the table to my advantage and use it to roll the cells into the fish paper. So we'll go ahead, align that nice there, and then I'll take this and we try to pull as hard as possible to keep the cell group nice and tight in there. And there you go, got a nice looking cell group. And we'll go ahead and take a short length of fiber tape, chop it off, take it along here, and wrap that nice and tightly around the cell group. And there you go, 13 more to go. All right, so we have gone and welded all of the cells together. I've got them sitting in a pile over there, but I'm starting to lay out the pack in the deck because the enclosure is much less restrictive than the deck. So all these cell groups are going to be back to back in the deck, and I'm probably going to solder them in, well, I might not solder them in here, but we'll see. My thought right now is all of these are slightly sitting outwards. So basically what I'm going to do real quick is tape together all of the 2S groups. So there'll be 7 2S groups all the way down, and they're going to be taped together to make sure that they hold nice and strong. And to make up for that little bit of concave, we can put some foam on the inside of the deck here. Now, the next thing that we'll be doing after that is soldering all of the connections for the series 1 through 14. Now, this is where it gets interesting because I'm still trying to decide how I want to do this. I'm thinking all of the middle connections will be the braid that I've been using before, so it'll just go across. And then the outside ones, I haven't decided if I'm going to do 2 times 12 gauge wire and have these bent over, and then the wires go across, or if I want to do braid and just go across this way. The only thing is this deck does flex a bit, and it flexes a bit consistently, so I'm concerned about having braid across here because I feel like it just isn't as durable to a lot of bending. So right now I'm leaning on the side of 2 times 12 gauge wire going from cell to cell out here. And it's not even that big of a deal because since the middle connections are handled by the braid, it's only really going to be, 1, 2, 3, 4, 5, like 7 connections of those cables. So I know there's space on the outside for them, so that's most likely what I'm going to do. But anyway, we're going to go ahead and tape up these groups, and then we'll be right back. All right, so I went ahead and taped all of these groups together across the way, and they're now set up how I'm going to be soldering them. Now, this will be using a similar technique to the race board battery in that the negative, well, on the race board is positive was at the front, but for this, we're gonna have negative at the front here, going all the way back, and then positive will be the short lead. Again, not really a big issue with doing that, especially at these small distances and with high strand 10 gauge cable. So now we're going to do something interesting with the soldering for the series connections, because basically what I'm going to do is I'll go ahead and this is going to be our positive, this is going to be our negative. We're going to go ahead here and just bend over the nickel strip out flat, and we're going to solder across and then bend it down the rest of the way, because if I were to stand it up like this and then solder across with them both standing up, that means that I would be putting heat straight into the back of the cells, and this way the heat would have to travel through the nickel and then disperse across the whole cell face, and that's just really not going to be a problem. So we'll go ahead and do that, go across, bend them all outwards, which is going to look super funny. And then I went ahead and pre-cut my pairs of 12 gauge wire. We're using purple and blue for this, and they're going to go across here, across there, here, there, and there. And basically we'll do all that, and then I'm going to leave off the end ones so I can solder on the positive and negative leads before we move on to the next step. When I'm doing these big batteries, I always like to go ahead and do a lot of my steps in batches. So right now I'm going to go ahead and prepare all of these cables by stripping off the ends to prepare them for soldering, and then we'll move on to making all these connections. Now, keeping with the spirit of batches, I'm going to go ahead and put some solder on each of these different joints. I'm going to make a little line so I can then just pre-tin each of these cables and melt them into place just like that, and then it will get bent down and the whole pack will be able to flex in this direction. So let's go ahead and start making those solder pools. All right, I've got all my solder pools now, and now I got to pre-tin all of these pieces of wire. So what I'm going to do for each of these is come along and use my flux, put some flux onto the cable, just like that, and like that, and then we'll go ahead and pre-tin it with a decent amount of solder, just like that, and like that. And then we're going to go ahead and take this pre-tinned bit, make sure our soldering iron is good and hot, and we're just going to solder it up there. But first I'm going to finish pre-tinning all these cables. All right, we've got all of our cables pre-tinned here. I went ahead and soldered this first one to make sure everything was going to work out all right, and it does. So basically what I'm going to do is just go ahead and put a generous amount of pre-tinned solder onto the tip, and we're going to set down the blue cable, pinch it up right next to the purple one. Put it right next to the purple one and melt it right in there. It's gonna take a minute. Well, not a whole minute, but it'll take a few seconds for the solder to soften. But that's fine because we're not really putting any heat into the cell, and I'll show you better in a second. I was just blocking that. if I feel right here underneath the cell, there is no heat being transferred back in. So that is perfect. That is exactly why we're doing it like this. So again, generous amount of pre-tin. Squish the cable up, and then we'll go ahead and melt it right in. Make sure you get that nice contact there with the nickel plate. And we can go ahead and add a little bit of solder afterwards if it looks like it's not going to be enough. And I do want these to all be nice solid joints, so go ahead and make sure they're all melted together nicely. The reason I'm doing a raising and lowering technique is because I know it's already hot and I don't want the cables to move, so. There we go. And then we'll go ahead and dry it. Cool rather. And we'll do the same on this side as well. And there we go, we've got our first solder joint.
All right, as you can see, we have now finished all of the cable series connections, and each of these is still flexible in the middle there, which is great. Now we'll be able to bend them down and the pack will be able to flex as it should. And you'll notice some of these are not exactly the same length. Too bad, it is what it is. I'm not going to worry about it too much because I'll never see the back end after I cover it all in fish paper and whatnot. So next up, we have to do all of the series connections across the middle. So here, 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 and here. So we're gonna cut a piece of braid for each of those and then solder them all on. All right, so before we go ahead and do all of the crisscross connections like I was talking about, we're going to do the negative and positive leads. So right now, we're going to lay out the length of cable for this negative lead that has to go all the way back here to the ESC. And I'm probably gonna run it along the side here with some fish paper to insulate it from all the different groups. And then for the positive group, we're just going to have a short lead coming off the positive here and going to the battery, to the ESC. But I'm going to cut those and then we're going to solder on the X290S before I hook them up to the power leads. And then we'll go ahead and make the rest of the connections all the way up the pack. Now, normally along with this long negative discharge cable, I would run a B- cable that would go to the B- on the battery and then to the BMS, but I think I'm just going to splice it out on this 10 gauge cable to make it a little bit easier, and that way I don't have to run two cables the entire length of this pack, and that way it can just charge back through the same cable that it discharges from. So I'm gonna end up splicing down here somewhere out of the way and make sure that that all works out properly. All right, so we've got our cables cut and I have prepared the negative discharge lead for the splice into the B- on the BMS. Now, I stripped out quite a bit of this B- cable so I could go ahead, wrap it around here, and get a nice solid connection on the cable like that. So I'm going to grab my helping hands to make sure that it gets held in place, put some flux on here, and we'll solder it up. I'm probably going to pre-tin. Actually, I'm not sure I'm going to pre-tin either of them. I think that this will work just fine without pre-tinning as long as we put in the right amount of flux, and then we'll go ahead and solder this onto the negative of the discharge for the whole battery.
All right, we've now got the positive and negative leads soldered on. So you go ahead and pop on the cover, and there we go. Nice and covered up. And now we'll go ahead and slide a nice piece of heat shrink tubing over this joint to make sure that that's all covered up. All right, so we got the cable laid in here, just ready to go. And I'm going to go ahead and solder on the positive lead to the positive terminal. So we'll go ahead and bend this over, strip off some cable sheath, and then solder it on. Now we've got the solder joint set in there. I'm going to go ahead and hold it in place and add a lot more solder because obviously that is not enough for a secure joint. Now that we've got the positive and the negative soldered on, I'm going to go ahead and fold all these tabs down, which I'm sure is something that some of you have been waiting for because they look super awkward stuck out like this. So I'm going to go ahead and fold these all down. All of these are going to get a nice tape job once everything is all together, and we can set the pack outside of the enclosure, or rather outside of the deck, and finish that off. Now, you may be wondering about how far down these come, and I have double checked in the enclosure and we have absolutely gobs of room on the sides here, so I'm not worried about that at all. This enclosure specifically made for the Hummie double stack is super wide, much wider than the one in my old Hummie build, so I have no problems with the extra width that we've got here. Now this is going to run along the side. Maybe I'll run it along the bottom like this, and we'll put some insulation between the sides of the cells and this cable to make sure we don't get any kind of rubbing. And there we go. Now it looks like a real battery pack. So next step is to do all of these center connections like I've mentioned a couple times. So I'm going to go ahead and cut out all the pieces of the braid, and then we'll just go ahead and do them all in a row. All right, so we got our battery laid out here, got the negative and positive soldered on, and now we have to lay out all of the balance leads. So this pack is a little bit different than the race board pack because the BMS is at the opposite end of the pack, which means that the wire layout is going to look slightly different. So I always start from the negative end of the pack, so you can see on the connector here that you got the black wire, which is the negative. And that is all the way down here, but the BMS at the other end. So the negative lead is actually going to be the longest run of this pack. So we might have to extend it a little bit, we'll see. And for the balance wires, I'm basically just going to run them straight along the pack like this, and
The Hummie deck does flex a little bit, but not too much, so I'm not worried about that. Basically, I'm just going to have them run along here, glue them in place in a couple spots, and then they will tag off to each of the different cells. And now if we're counting across the pack, you have to follow the path. So this will be 1, or 0 rather. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then the last one there. I think I missed one, but basically it's not going to be straight. So I'm going to split up the wires in such a way that there's none that are crossing awkwardly, and to help do that, I'm going to go ahead and write a number by each of the different spots, and then we'll come back. All right, so I went ahead and labeled all the numbers here. I'll just record a quick clip with my phone to show you from top down. If you look from top down, you can see BC0 here, BC1, BC2, BC3, 4, 5, 6, 7, 8, and so on. And the reason I label it like that is because if you look at the LLT BMS, BC0 is the first one and BC14 is the last one. So that's just how I did it. And if it helps you to do it that way, then feel free. But anyway, you can see here that we're gonna have a little bit of an annoying path because we have to crisscross. But I think what I'm gonna do is I'll be able to lay out all 14 wires on this side. And then for every crossover, I'm just gonna run it down the channel between the cells and over to its respective place. So maybe it won't be as bad as I think, but we're gonna find out pretty soon here. Alright, so I went ahead and laid out all the balance wires. It's probably not going to make a whole lot of sense looking at it like this, but laid them all flat out here. You can see black is the longest one, and then it goes down from there. We've got a couple of spots where the wires are crossing, so in each of these spots I'll make sure that they're glued down well so they're not going to rub against each other. And then all the rest are pretty simple. I'll put them in the channels, go around, solder to the end, and shouldn't be too bad. All right, so we got these 3 leads extended, and I soldered on the main negative one already. So now we're just going to continue on and solder on the next one, which is BC1 right here. And this is pretty simple. All we have to do is make a little solder pool on the corner here, put some flux on the end of the wire, and melt it into the solder pool. Pretty simple.
Alright, so we've gone ahead and soldered all of the balance wires up. I haven't checked the connector yet to make sure they're right, but we'll make sure to do that before we plug it in. Now, the only ones left are, well, the only single one left is the positive, which will be going right here onto the 14th series cell. Now, there's also 2 other cables that I need to connect here. One of those being the charge positive, which will go to the positive on the charge port, and then a discharge for my lights. and this will get plugged into this little switch module, and I'll show you the wiring for that later. But right now we're gonna solder on the C+, the lighting plus, and the 14th balance wire. Now, one of the other things we have to do with the positive leads down here, well, technically this isn't 100% necessary, but I still like to do it. The positive of the charge port, I like to put a fuse on that just in case the charge port is ever to get shorted. Now, technically most of these BMSs nowadays are good enough to protect the battery and themselves from short circuit, but easier to just have this here anyway, so we're gonna go ahead and put that in line on the charge positive. One other thing that I like to do with my charge ports is make them removable. So this charge positive is actually going to go to the positive of another XT30 connector. So we're gonna go ahead and solder that on here right now. All right, so I went ahead and soldered the fuse into the C+ line, and then of course on the opposite side I went ahead and soldered the C- line. Now C- is going to have to connect to C- on the BMS, and then we're also going to have to splice in another cable to go to my switch module, which is actually this. So we're going to attach a cable from this negative into the C-, and it'll be a three-way splice there. Now there are probably a couple different ways you could do this joint, but this is the way that I have found that works pretty well, is just by jamming together the open cables and then using a good amount of flux and soaking the whole joint together to make sure that it all melts into one nice piece. And that is kind of far away for you to see, so I'll bring you a little closer. All right, so I went ahead and took some measurements on the balance connector to make sure that everything was right. And when you do that, you can stick your multimeter probes in here as long as you're being careful. Measure from the black negative and go one cell at a time, and it should count up for this BMS anyway, all the way to the full pack voltage at the red, which we just connected onto the positive over here. So the battery is technically ready to be discharged from. However, it's not looking very well. It looks fine, but there are some things that need to get glued down. So I'm going to go through and glue in a bunch of different places, clean this up, probably put some glue on each of the balance wire connections, and then we're gonna have to take this out of the board and wrap some fish paper around the bottom parts. And I'm probably gonna tape these in groups of 2 to make it a little bit stronger, because this deck does flex, but not a ton, so it's okay if the groups of 2 are not all together, if you know what I mean. So that's pretty much it. I'm also going to glue the 1 temperature probe onto my charge port connector, which is what I usually like to do, so I can monitor charge port temperature. So I'll glue it right there like that. And then the next step after that is we're going to have to change out the bullet connectors on the ESC. But that I'm going to save probably for a different video, because that's not really battery related. And in fact, we did actually do a lot of non-battery related stuff here to get it ready for the full build, but hopefully you guys found that interesting anyway. So let's go ahead and get on to gluing up the battery. Right now we're going to go ahead and configure the BMS in the app. So we're gonna set this to 6 times 4, which is 24 amp hours. And then cycle capacity is 80% of that, which is gonna be 18 amp hours. Now, you can see all of our cells here. It auto-detected properly. This is technically an auto-detect ESC, BMS that can do from, I think, 4 to 14S or something, or no, 7 to 14S, but obviously we're using all 14S. And you can see that all of our cells are in pretty good health, pretty balanced. Some of these are kind of old, so it's not surprising that they're not 100% perfect, but they should balance out when we give it a charge. Now there's a couple settings I'm going to change in here, and then we'll be all done with that part. Alright, so I went ahead and turned over the battery so we can put some tape along the bottom. As you can see, there's still a lot of shifting here, and we want this to be flexible. So first off, that means we can't put heat shrink over the whole thing, because then it will just become a brick. So right now what I'm going to do is, if you remember on top, I combined the first two, the second two, the third two, and then the end one I left floating, I believe. I'll have to double check, but we're gonna go ahead and tape here, 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 and then I'm going to take some tape and excuse me, and make sure that these are all pressed down against here. Then we're going to put some fish paper in the enclosure, in the deck along the inside of this edge. And then we'll move on to some more finishing touches and finish off the video. So I decided the way that I'm going to keep this flexible and still put fiber tape on is I'm going to put fiber tape down into the crevice. And then that should leave it still able to flex a little bit, which is what we want for this particular deck. So I'm going to do that now. Alright, so I got the tape all done on the bottom, and it's still fairly flexible, more like movable, which is fine. I got it laid up on the side here so I can strain relieve each of the balance cables with some hot glue, and then we're going to firmly tape down each of these connections and insulate over this nickel to make sure that when we run this cable along the side, it's not going to have any chafing issues. So let's go. Alright, so I went ahead and taped everything off, and basically what I did here is I used fiber tape to hold down the nickel to make sure it stays in place, and then I went over it with a layer of Kapton, and then put the cable over and used more Kapton to tape that down. Now, the reason I'm doing that and not using fish paper here is because this whole cable and these whole sides will in fact be touching nothing in the enclosure except for the foam that I use to hold it in place. So really there shouldn't be very much vibration here at all, and I'm just gonna check it after I don't know, maybe 100 miles and make sure that everything looks good, but we really should have no problems here with any kind of vibration or chafing. So now we're gonna go ahead and do the other side. All right, so I went ahead and taped off this entire side, strain relieved all the balance wires, and for anyone who was hoping that this would be symmetrical, sorry. But anyway, the pack is nearly done. You can see these are still technically separate sections, but they are taped underneath, so they can only move so far. And now all we're going to do is insulate the top pieces of nickel with some Kapton tape, and then we will be able to stick this in the enclosure and get it all padded up. Alrighty guys, we have finished the pack, and I'm sure you all will have seen the B-roll that I took by now, and pretty happy with how this pack came out. It's definitely different than all of the packs that I've done in the past. For the particular build that this is going in, the Black Mamba build with the Hummie deck and the carbon fiber enclosure, I had to put together this very specific layout, and I wanted to get the maximum amount of cells possible with a good amount of range, which happened to be 14S6P. So here we have our completed 14S6P battery, which is flex capable. So I wouldn't say that this is a flexible battery necessarily, but it will perfectly put up with the amount of flex that the Hummie deck has, which is very little. And I think the carbon fiber enclosure will reduce that even more, but we will see. So yeah, I'm really happy with how this pack came out. I've got a little bit more work to do before it's able to actually power the board. And the reason that I have more work to do is because I've got my lights to hook up, and I've got to solder the charge port onto an XT30 mounted on the enclosure. I've got to get the enclosure mounted, so we've got a good bit of work left to do before this board is rolling, but this is a huge step towards that goal. So hopefully you guys have enjoyed this instructional video, a little bit different than some of the other battery builds I've done. And I know that this is going to be a long one because I've paid attention to how much footage I've recorded, and there's quite a bit. So hopefully you guys enjoyed, hopefully you learned something, and hopefully this helps take a little bit of the stress out of DIY battery building. It's definitely possible, and you can do it yourself as long as you are careful and pay attention to all of the little kind of safety tips that I give along the way. Now, please remember, anything that happens with your batteries, I do not take responsibility for. I try to show the best practices of today's battery building in my builds, and I believe that I execute that pretty well. But if you have any questions, please leave them down in the comments below, or reach out to me on the eScape forum. We have a whole battery builders thread, and people get questions answered there all the time. So please let me know. And if you like the video, give it a thumbs up. We recently hit 1,500 subscribers, so thank you so much for that. And if you're still here all at the end, you are awesome. So next video in this series will be the final assembly of this board, so make sure you get subscribed for that. And stay safe, keep on riding, and peace out.